What's going on, y'all? We are going to learn about the area of regular polygons today. So without it, let's go ahead and get to it. So if you need to remember one single thing, that would be this formula. If you have a regular polygon, so regular means all sides are congruent. It's that the area is going to be 1/2 AP, where A is the apothem, and I know you don't know what that is yet, don't worry about it, and P is the perimeter. All right. And the apothem is something like this. Let's say you got a triangle, you got a regular triangle. Here's the center of the triangle. So the apothem is going to be the distance from the center to the side. So this is A. And then this distance from the center to the vertex, to the vertex of the triangle or whatever figure, this is going to be the radius. So just a bit of vocab there, just to get you up to speed with things I'm going to be spitting out here. So let's go ahead and look at a reminder that you might have forgotten. So what you really need to remember is these special right triangles, especially this special right triangle. So remember, if it's across 30, it's just x. If it's across the right angle, then it's going to be double what was across 30. And if it's across the side across 60, it's going to be √3 multiplied by x. Okay, so you need to remember this for all of these examples, for like literally all of them. So let's go ahead and do our first example. So we are given this regular triangle, and what we need to do is we need to figure out its area. So before I even do anything, I'm going to write down our area is equal to 1/2 AP. Okay, so we don't have A or P or anything, but what we're going to do is we're going to use this special right triangle to figure all these things out. So let's go ahead and make one. So if we take a look here, this is going to be 90 degrees. And if you have a regular triangle, each one of these angles is going to be 60. So this whole angle here is 60. So this small angle is going to be 30. So since we have a 90 and a 30, we can say that this is a 60. And lo and behold, we have a 30, 60, 90 triangle. My gosh, why would I remind you of this? It's crazy. So now we can find all the side lengths. So this is our hypotenuse. It's across 90. So the side across 30 is going to be x. So it's going to be half of 2x. So this is going to be 2. And then from the other side length, the medium side, is going to be 2√3. So for this, that means this whole side length is going to be 4√3 because it's double 2√3. So our perimeter, since there's 3 sides, is going to be 3 times 4√3. So this is how many sides? And this is the length of each side. So that's going to give us our total perimeter. So we can plug stuff in. So area is equal to 1/2 A times perimeter. Well, this is going to be equal to 12√3. So we can put in parentheses 12√3. And our apothem is going to be 2. We actually just solved for that by looking for all these sides. So A is equal to 1/2 times 2 times 12√3. Now we just have to evaluate this. So we have a 2 divided by 2. So these are going to cancel out or make a 1 or reduce. So the area is going to be equal to 12√3. And that is going to be it. All right, so here's the next example. Find the area of a regular triangle with side length 8 inches. So here's our regular triangle. I don't know what that was. We got a regular triangle. We got a side length of 8 inches here. So that means our perimeter is going to be 3, number of sides, times 8, which is equal to 24 inches. So we have A is equal to 1/2 AP. We already know what P is, so we got to find A now. So if one side is 8 inches, that means this length is going to be half of that. So this is going to be 4 inches. Now we have to find out what A is, which is right here. So we have our 30, 60, 90 triangle. And if you remember our special right triangle rules, you know what? I'll even orient it the right way just for y'all. Here's 30, here's 60, and here's 90. This is going to be x, x root 3, and 2x. So how do we get from x root 3 to x? Well, we have to divide by root 3. So A is going to be equal to 4 divided by square root of 3. And what mathematicians like to do is rationalize the denominator for some reason. Don't ask me, I didn't make the rules. So we got to multiply the top and bottom by square root of 3. So at the top, we're left with 4 square root 3. And at the bottom, we're left with root 3 times root 3, which is just 3. So here is the length of our apothem. So now we can plug all of this stuff in. So A is equal to 1/2 4 root 3 over 3 times perimeter, which is 24. So now we can multiply all this stuff together. So at the top, we have a 4 and a 2, so we can reduce these. This becomes 2 root 3, and this becomes a 1. And we have a 24 and a 3, so we can reduce this. This is 24 divided by 3, so this becomes a 1, and this becomes 8. So after a lot of reductions, we have 2 root 3 times 8, which is equal to 16 root 3. And we have units, which is inches, so this is going to be inches squared. All right, so we're going to move on to the area of regular hexagons. And this is going to be the only other shape that we're going to ask you for. So it's going to be triangles or hexagons. And the reason being is because this also happens to use 30, 60, 90 triangles. So if we make a triangle right here, well, first let me tell you that all of these angles are going to be 120. So that means this small angle is going to be 60. And this is 30, and here's 90. So we have a 30, 60, 90 triangle like this. So this is x, here's x root 3, and here's 2x. So in this case, we have our medium side, and it's 4 root 3. So we want to get this side right here. So how do we go from x root 3 to x? Well, we have to divide by root 3. So 4 root 3 divided by root 3 is just going to be 4, which makes one whole side 8. So let's write down our formula. Our area is 1/2 times AP. So P is equal to the number of sides. Well, hexa means we got 6 sides. And then times our side length, which is 8. So our perimeter is going to be 48. And then our apothem, well, it's given to us. This is our apothem. So we can say A is equal to 1/2 times 4 root 3 times 48. And let's go ahead and simplify this a bit. So 4 divided by 2, and that's going to reduce to 2 root 3 here. So we have 2 root 3 times 48. So we're going to be left with 2 times 48 is 96 root 3. So this is our solution to this. And I have one more example for you. Find the area of a regular hexagon with perimeter 24 feet. So let's do our best and draw a regular hexagon. I am not the best drawer in the world. I am well aware of this. Don't roast me, please. All right, so we got perimeter is 24 feet. So this is nice. We're already given our perimeter. So what does each side length have to be? Well, if the whole thing is 24 and we have 6, that means each one's got to be 4. So this is going to be 4 feet. So here's our center. Let's go ahead and draw our triangle right here. So since this whole thing is 4, half of the side is going to be 2. And we have our 30, 60, 90 right here. So this is 30. Our apothem is going to be 2 root 3, 2 times root 3. So now we have everything we need. We have our formula. Area is equal to 1/2 times AP. So we just got to plug stuff in. Area is equal to 1/2. Our apothem is 2 root 3. And our perimeter is 24. So these two, they cancel out, or they reduce, whichever you like. So we are just left with 24 times root 3. And we have units. It's feet, so we're going to have feet squared. And that is it for the area of regular polygons.